Welcome students. So here we have come again with the next episode on chapter light. So light we are now covering the topic refraction. So already I uploaded some videos on reflection and the basic concept on light. Okay, if you missed my previous episode, you can go through the channel Physics Scholar and you can subscribe it. Okay, for the update for the next update. Okay, so one by one from the basic part to the higher part will move. So if you continue to watch my channel, I think the idea on light will be clear for you. Okay, so up to class 12 students can see these episodes, and later on I will also upload some content of college levels. Okay, so keep watching. So now today, yesterday, in the previous video, I discussed on refraction. What is refraction? Okay, then laws of refraction, Snell's law. Okay, the second law of refraction, and then I discussed about the how the direction will change. Okay, when the light is coming from rarer to denser or denser to rarer. Okay, and next I also discussed about the critical angle. Okay, and about the total internal reflection. Now today we will learn some relationship, okay, between the refractive index, absolute refractive index, and critical angles. Okay, so some relationship we will now discuss. So first, so what we know, suppose it is medium A, it is medium B. Okay, it is medium A, it is medium B. Ray of light, suppose it is rarer medium, and suppose it is denser medium. Okay, denser medium. So if a ray of light coming from rarer to denser, you can say that yesterday I discussed it will bend towards the perpendicular drawn. Clear? So suppose it is angle of incident I, it is angle of refraction R. Okay. So what is the Snell's law? What we can write? The refractive index of medium B with respect to medium A, we can write like this: A mu B is equal to what is Snell's law? Sin I by sin R. So it implies the refractive index of the second medium or the medium B with respect to the first medium. In my previous episode, I discussed about this. So the direction of light is reversible. So suppose the same thing, same medium A and B. Suppose the light is coming from medium B. It is the perpendicular drawn and entering to medium A. So it is what? It is rarer medium, and it is denser medium. So now this angle what? This angle will be now R, and this angle the same thing, because right is reversible. So what we can write? The refractive index B mu A. Okay, that means refractive index of A with respect to B is equal to sin. Now this is the angle of incidence, so sin I by, this is the angle of refraction now, sin I. Okay, so if it is equation number 1, if it is equation number 2, then we can multiply equation number 1 and 2. What we can write? A mu B into B mu A is equal to what? Sin I by sin R into sin R by sin I. That means it will be cancelled. So the result will be 1. So what we can write? A mu B into B mu A is equal to 1. So what we can write? A mu B is equal to 1 by B mu A. That means what? Refractive index of medium B with respect to medium A will be what? 1 by refractive index of medium A with respect to medium B. So this is the relation, okay, of the refractive index. Okay, when the light is coming from medium A to medium B, then the refractive index of medium B with respect to medium A, and when the direction is reversed, then what the refractive index of medium A with respect to medium B. That means this is the relationship between the refractive index of the two medium, this denser and rarer medium. When the light is coming from one medium to other medium, the relationship between the two refractive index of the two medium. Okay, so this is I think this is clear. So A mu B is equal to 1 by B mu A. Okay. So I have discussed about the refractive relationship of refractive index between the two medium. Okay, when the light is coming from one medium entering into another medium. So A mu B is equal to 1 by B mu A. Okay. Now relation between refractive index and absolute refractive index. Okay. So relation between refractive index and absolute refractive index. So suppose the two medium are there, A and B. Two mediums are there, A and B, and the absolute refractive index I discussed in my previous episode. Okay, what the if the first medium is vacuum, okay, then the refractive index of second medium is known as absolute refractive index. If you missed, you can go to the previous episode. Okay, so if A and B are the two medium and absolute refractive index of medium A is suppose mu A, and absolute refractive index of medium B is suppose mu B. Okay, so what we know, suppose the velocity of light, okay, velocity of light in medium A is what, VA, and velocity of light in medium B is suppose VB. So what we know, absolute refractive index mu A is equal to what, velocity of light in vacuum divided by what, velocity of light in medium A. So suppose velocity of light in vacuum is C, then what we can write, C by VA. Here similarly what we can write, mu B, absolute refractive index of medium B, velocity of light in vacuum divided by velocity of light in this medium, that I have discussed in the previous episode. Okay, so what we can know, can write now, mu A by mu B is equal to, what is the value of mu A, C by VA divided by C by VB. So C by VA into VB by C. So VB by VA. Okay. So what we can write, A mu B is equal to VB by VA. Okay. So this is what, this is the relationship of the refractive index, absolute refractive index, with the velocity of light. Okay, mu A by mu B is equal to VB by VA. Okay, so this is the relationship of absolute refractive index and the velocity of light. Okay. Okay, now the next topic is refraction through parallel glass slab. Okay. Refraction through parallel glass slab. Okay. So suppose this is the glass slab made of glass. Okay. The opposite sides are parallel. Now this is the ray of light. This medium is now air, and this medium is glass. So this is the perpendicular drawn. This is suppose I1. So the ray is coming from, it is what? Air is rarer medium. It is rarer medium, and it is denser medium. It is denser medium. So the refracted ray will bend towards the perpendicular. Okay. And here, suppose this is R1, this is R2, and this is I2. Okay. So this is the path of light. Okay. So suppose A, B, C, D. So here incident ray AB and emergent ray CD. Okay. So I am explaining now. So here AB ray from the air medium incident on the parallel glass slab on point B, and as it is entering from rarer to denser, so the refracted ray will move towards the perpendicular, and this is the path of light inside the slab. And for this point C, okay, this will be the incident ray and this will be the refracted ray, and it is ultimately coming out from the slab, so we can say it is the emergent ray. Okay. So at this point the angle of incidence is R2 and angle of refraction is I2. Okay. So it is medium A or air, it is denser medium glass, so we are representing it as G. So what do we know from Snell's law for point B? Okay, from the first case, it is the second case. It is for first case, angle of incident is I1, angle of refraction is R1. So what we can write? A mu G, refractive index of glass with respect to air, A mu G is equal to what we can write? Sin I1 by sin R1. Okay, sin I1 by sin R1. Now for this point C, what we can write? For point C, okay, what we can write? It is G and it is again air medium A. So refractive index of A with respect to G. So that means G mu A is equal to what we can write? Sin, it is what? R2 divided by sin I2. Okay. So again what do we know? Just before, at the beginning of the episode, I have discussed A mu G is equal to what we can write? 1 by G mu A, that you can write. So what is the value of A mu G? Sin I1 by sin R1 is equal to 1 by what? Sin R2 by sin I2. Then ultimately what is coming? Sin I1 by sin R1 is equal to sin I2 by sin R2. Now from this diagram, you see R1 will be equal to R2 from the diagram. Okay, as R1 is equal to R2, that means what we can write? Sin I1 is equal to sin I2. That means what? Angle I1 is equal to I2. That means this angle and this angle, two angles will be same. So this proves that the incident ray and the emergent ray will be parallel to each other. As this angle and this angle will be same, so these two rays will be parallel to each other. These two rays, this should be the path. Okay, these two rays are parallel to each other. Okay, and there will be no deviation of light, only there will be a partial shifting. Okay, partial shifting of light. Okay, so this is the relation. So this proves that the emergent ray and the parallel and the incident ray and emergent ray will be parallel to each other. Okay, and there is no angle of deviation of light. Okay, but there is a partial shift of light. Okay, so this is the diagrams of the refraction of light through parallel glass slab, and this is the proof when we can prove that the incident ray and the emergent ray are parallel to each other. Okay, and there will be no angle of deviation of light but a partial displacement of light. Okay, so hope you understand this topic. So let us move to the next point. So students, next topic, relation between critical angle and refractive index of denser medium. If you meet my previous episode, what is critical angle, what is the condition for critical angle, okay, then you have to see my previous episode. Okay, so suppose in case of the critical angle, okay, what is the first condition? The light must have to travel from denser to rarer medium. So suppose this medium is denser medium, water. Okay, this medium is water, or we can identify it as W, and this is medium is air. So we can write it as A. So it is also rarer and it is denser. It is denser medium. Okay. So suppose the light is coming from denser and entering into rarer. So this angle is 90 degree and this is C. Okay, angle, or we can write it IC, critical angle. Okay, so the angle of incidence in denser medium, for which the angle of refraction in rarer medium will be 90 degree, this angle is known as critical angle. Okay, so what we can write? As light is going from denser to rarer, okay, so W mu A, that means refractive index of A with respect to W. Okay, so what we can write? Sin I. What is sin I? Here IC. So sin IC divided by what is R? R is equal to 90 degree. So sin 90 degree. Clear? So W mu A sin IC divided by sin 90 means 1. Value of sin 90 is 1. So what we can write now? Sin IC is equal to W mu A. But what we can write? I have shown W mu A is equal to what? 1 by A mu W. That means sin IC is equal to 1 by A mu W. It is what? Refractive index of denser medium with respect to rarer medium. So refractive index of denser medium with respect to rarer medium. Or we can write it A mu W is equal to 1 by sin IC. Okay. So this is the relationship between the refractive index of denser medium with respect to the rarer medium. Okay. Along with the critical angle. Okay. So critical angle, okay, of the denser medium. So this is the relationship. So students, hope you understand this. So let us move to the next topic. Okay, students. Now let us move to the next point. View of an observer from inside water, or you can consider it suppose fish. Okay, the observer you can consider as fish or anyone. So suppose all of you listen it carefully. So it's the concept of total internal reflection as well as the critical angle. Okay. So suppose it is water or pond or tank, whatever. It is water. Or we can assume as medium W. And this is air. We can assume as medium A. It is rarer and it is denser. Okay. So suppose here the eye is there. Eye is there of the observer. Okay. So from this point we know the critical angle of water with respect to air is 49 degree. 49 degree. That means what? The critical, the A mu W, okay, the critical angle is in case of that is 49 degree. Okay, that means if the angle is more than that, then total internal reflection will take place. So suppose this is the ray, suppose this angle is 49 degree, so this will be the refracted ray, and here this angle will be 49 degree and this will be the refracted ray. And for any other angle, for any other rays greater than 49 degree, total internal reflection will take place. Okay, and that part it will not be visible. Okay, total internal reflection will take place. That means no rays can go to the air medium. Clear? That's why that part will not be visible for the fish or for any observer. Okay, so what is the maximum at the both sides? What is the range? What is the range of the angle on the both the sides? Suppose this angle will be same. So this angle will be 49 degree and this side, this angle will be 49 degree. So what is the total? This is a cone. This is a particular cone. Okay. So the angle of the cone will be 49 plus 49. That means 98 degree. Okay. So the fish can see 98 degree. So the fish can see any object. Okay. So that particular this area just like holes, okay, of this cone. Okay, so in the cone you can prepare this just like a hole. Through that the fish can see whatever the object is coming within this range, the fish can see that. Okay, if any object is outside of this range, the fish or any observer cannot see that. So any observer can see the object from inside water to the air medium within area or within a range of a cone of 98 degree. Okay. Now we can also calculate the radius of the cone. Clear? So what is the reason for that? Because we know that the critical angle of water with respect to air is 49 degree. So if the angle of incidence is more than 49 degree for all that rays, for which the angle of incidence is more than 49 degree, the total internal reflection will take place. So that part will not be visible by the observer. Only up to 49 degree, okay, on the both sides the things will be can be visible. Okay, so that is the reason. So that's why if any observer, the angle of this cone will be what? Angle of this measurement of the angle will be 49 plus 49, that means 98 degrees. Okay. So students, today up to this. In my next video, I will discuss how to calculate the radius of that particular cone's clear relationship between the depth and some phenomena, okay, on critical angles and total internal reflections and also the refraction of light. So, and then we will move to the numeric problems, okay, for class 10, class 12 standard as well as joint JEE main, advanced or NEET, okay, standard. So, to continue, watch my video, subscribe Physics Scholar, and hope it will help you. Thank you.